Alright, in this video we're going to talk about Unit 10, Objective 1, area between curves. So we've seen in the past how to find the area below a curve. We just take an integral from a to b. But what we're going to be looking at now is when we have two different curves and we want to find the area in between them. So if we have two different curves, let's call this first one f of x. And we have another curve. We'll go like this and call that one g of x. We have found before the area under f of x, the area under g of x, but what we're going to try to find in this objective is the area in between them, so this area here. So if you look at that area, you'll notice that it is still part of that area under f of x, but we've taken out the area that's under g of x. So to find that blue area, we would want to say the integral from a to b of f of x minus g of x. And how I want you to think about this is the top function minus the bottom function. So if you're looking at your graph, the top function in this one is f of x, it's the blue value. The bottom function is g of x, it's the red function. Now the a and b are going to be where those two graphs intersect. So this point here would be a, and this point here would be b. Generally speaking, you're going to see this on a free response question that is more often than not going to be a calculator, because you're going to have to find those intersection points. Either that or you'll have one of your functions being a linear function, so it's pretty easy to find the intersections there. Now we can also look at this type of problem and integrate with respect to y. So if I were to draw another graph that looked like, I'm going to change colors real quick. Let's say we had, call that f of y. So no longer f of x, but f of y. It's a function of y, not a function of x. It doesn't pass the vertical line test, but it does pass the horizontal line test. So we can call it a function of y. So that's f of y. We can call that g of y. And again, to find the area in between those two curves, instead of thinking top minus bottom, we're going to think right minus left. So we're still going to say the integral from a to b of f of y minus g of y. In this case, we'll say dy. But now we want to think the right function minus the left function. And one thing to be careful of, the a and b in this case are going to be y values, because everything we're dealing with when we're integrating with respect to y, your a and b are going to be y values. So you have y values here, instead of the traditional x values that we deal with. So sometimes it will be written in such a way where they'll say, over here we can say that x equals y squared. It's actually negative y squared. And this function would be x equals y squared. So that's how we're going to know we want to integrate with respect to y. It'll say x equals something in terms of y instead of y equals something in terms of x. Now there's one other thing that we have to be careful with when we're trying to find the area between curves, and that's if our functions change places as far as what's on top and what's on bottom. So if we have another couple of functions, so we'll call this first function again, we'll call it f of x. And then we'll call this second function g of x. If we're trying to find the area in between those curves from A to B, you'll notice that that first section that we're trying to find, right, we can see that there's two sections of area. We have this area here, we have this area here. In that first section of area, f of x is the top function, g of x is the bottom function. And if you look at the second one, g of x is the top function and f of x is the bottom function. So what we need to do in that case is find this other intersection point here, we'll call it C, and we just want to take two separate integrals. We'll want to integrate from A to C of our top function f of x minus our bottom function g of x with respect to x, and then we just want to add to that the integral from C to B of our top function g of x minus our bottom function f of x. And that would work the same way if you're integrating with respect to y. So this kind of allows us to make a choice if we want to integrate with respect to x or y using one integral or two depending on the function. So sometimes we have to break it up. Sometimes we'd be able to integrate with respect to y and it wouldn't be a problem. So that'll do it for this video, and we'll see you in the next one.